Hi everybody, welcome to another video in College Algebra, section 1.6, other type of equation. On this section, we'll study different types of equation. The first one is polynomial equation. So polynomial equation is the equation where we have polynomial on one side and zero on the other side. Something like this equation can be written as a polynomial equation if we can rewrite that so that 0 is on one side. So in this case, just subtract 2x and subtract 5 on both sides. So we have equation polynomial in this form. So in this section, we only focus on solving the equation only using the factoring method. We spend the whole chapter solving polynomial equation later. Right. For factoring, these are some useful identities. Difference of two square, a square minus b square is a minus b, a plus b. Difference of two cube, or the sum of two cube. Here, how good I remember it. So first we have, it could be minus or plus. The first one is going to be the same. The second one is going to be opposite. And the last one is going to be positive. So if it is a cube minus b cube, the first is going to be the same. The second side is going to be opposite. And the last one is going to be positive. Right. Now let's look at this equation. First example, 3x to the fourth power equal to 81x. So first thing we can do is subtract 81x on both sides. And so we will have 3x to the fourth minus 81x equal to 0. Both of them have x and both of them divisible by 3. So I can factor out 3x. Now, 3x to the 4, take out the 3. There's nothing. There's 1 left. 3 divided by 3 is 1. And then x to the 4, take out 1x, we have x cubed left. 81 and 3. Take out the 3, or 81 divided by 3 is 27. And we take out an x, so this minus 27. So we have a cube, and 27, if we can rewrite as a cube, we can use this equation, this identity. So if I write 3x, x cubed minus 3 cubed, and use this identity, we will have x minus 3 x squared plus 3x, or x times 3 plus 3 squared equal to 0. So here we have 3x, x minus 3, x squared plus 3x plus 9 equal to 0. Now we have it, the polynomial is factored completely, and the zero factor theorem, zero product principle. So we will have 3x, each of the factor must be equal to 0. Uh, 3x equal to 0, so x equal to 0. Divide by 3 on both sides. That's simple enough. Divide by 3 on both sides. So that's one of them. And then here plus 3 on both sides. With x equal to 3. And this one, we have to use quadratic formula for that. Quadratic formula. So x equal to minus 3 plus or minus square root of 3 square minus 4 times 1 times 9 over 2 times 1. Minus negative 3. 3 squared is 9 minus 36. 9 minus 36. Minus 27 over 2. So we have negative 3 negative inside square root that imaginary I and square root of 27 over 2. And 37, if we practice it down, 27 is 3 times 9 or 3 times 3 times 3. If we take the square root, so that will be square root of 3 times 3. So 3 square root of 3. 3i square root of 3 over 2. So that's what we have. So this equation has 4 solutions. Right? Let's go to the next one. Polynomial equation. So we need to have 0 on one side, so move everything on one side. So we have x cubed plus x squared minus 4x minus 4 equal to 0. So as mentioned before, on this section we only focus on factoring method. All the method will be studied later. So here we have 4 terms. Why don't we just factor the first 2 terms and the last 2 terms? X cubed plus x squared can factor x squared. And then x cubed divided by x squared, that will be an x. And then plus 1. Minus 4x minus 4. Both of them have minus 4 in common. So we have x plus 1 equal to 0. Now we have x plus 1 and x plus 1 in common. Can factor it out. Then x squared minus 4 equal to 0. Now, x squared minus 4, if we rewrite as x squared minus 2 squared, then we can use the first identity here, the difference of 2 squared, where a is x and b is 2. So we have x plus 1, x minus 2, x plus 2, a minus b, a plus b. And now the rest is easy. Zero product principle. Each factor must be 0. So subtract 1 on both sides. So we have x equal to -1 plus 2 on both sides, x equal to 2. Subtract 2 on both sides, x equal to -2. Right, so that is the first part of this section. We study about polynomial equations. The second part is radical equation. So the equation that has a square root or cube root in it. But in this section, we only study about square root. Equation that has square root in it. Note, so in order to solve the equation that has square root in it, we have to get rid of the square root. And the way to do that is square both sides. So I put a little note here. When raising both sides to an even power, including square or to the fourth power and so on, we must check the answer. So just keep that in mind. Right, so when we have the square root, I will try to get rid of it. But in order to get rid of it, we just isolate the square root. So I subtract 2 on both sides. Isolate the square root first. And then we will try to get rid of it. So get rid of it, we will square both sides. When you do that, make sure that you will check the answer later. You know why we have, you will see why we have to check in a minute. Right, now the square, we cancel the square root. Right, so I have x minus 2 times x minus 2. I'll just multiply it out to x minus 1. X times x squared minus 2x minus 2x plus 4. Combine like terms. Negative 2x minus 2x minus 4x plus 4. Now, this is a polynomial equation. I try to move everything on one side. The reason we move to this side because x squared has a higher power. We just want to keep it. Just move everything to that side. So we have x squared minus 6x plus 5. Or we can say x squared minus 6x plus 5 equal to 0. Right. Check the equation later. Right. Next, this equation, we can use quadratic formula, completing square or factoring. This one, let's try factoring. So try to find two numbers, multiply together, equal to the first times the last. 1 times 5, and they have to add up together, equal to the middle number. And easily we can see that the product of 5, so 1 times 5 or negative 1 times negative 5 to get to to get to 5, I mean the product of 5 is 1 and 5, or negative 1, negative 5, and for this one add up to negative 6. So we split the negative 6x into negative 1x and negative 5x. Right, so I have x squared minus 1x minus 5x plus 5 equal to 0. And here I can factor the first two terms and the last two terms. The first two terms can factor out on x, then x minus 1, and then factor out of negative 5, x plus 5, x minus 1, sorry. And factor x minus 1, x minus 1, x minus 5 equal to 0. And continue here, we have a product equal to 0. 0 product principle says each factor equal to 0. So at least one of them is equal to 0. Plus 1 on both sides, we have x equal to 1. Plus 5 on both sides, we have x equal to 5. Right. So, and after that, remember, square both sides, check the answer. So, when x equal to 1, put 1 in the equation. 2 times 1 minus 1 plus 2 equal to 1. Yeah, just put 1 in for x. 2 times 1 is 2 minus 1, so we have square root of 1 plus 2 equal to 1. And we know this is not true because the left hand side is 3, the right hand side is 1. So 1 is not a solution. Now let's check for 5. If we put 5 in the equation, uh, 2 times 5 minus 1, so 10 minus 1 is 9, square root of 9 plus 2 equal to 5. Square root of 9 is 3. That check, so we have x equal to 5 as the solution. Right, so make sure we isolate the square root. So when we squared, square cancel square root, and when we squared, check the answer. The rest, we just solve the equation in the quadratic equation, pretty much. Right, same thing here on this one. So first, we'll isolate the square root. So minus 2x on both sides. So we have square root of x plus 2 equal to 6 minus 2x. Now we square both sides to get rid of the square root. Remember, every time we square both sides, make sure we check the answer at the end. So square cancel the square root, and here we have 6 minus 2x square. Square is multiplied by itself. So we have, just x plus 2. 6 times 6, 36. 6 times minus 2x, minus 12x. And minus 12x plus 4x squared. Right, combine like terms. 4x squared, forgot an x here, sorry, minus 24x plus 36. Move everything on one side and move to the right side. So we have 0, and this gives us 4x squared minus 25x plus 34. Right? So, or we say 4x squared minus 25x plus 34 equal to 0. So numbers is this big, so probably we should just use quadratic formula here. Right? So x equal to minus b, negative b, plus or minus b squared minus 4 a c over 2a. So we have 25. So inside the square root we have negative 25 square or just 25 square. Or negative 25 square, doesn't matter. Minus 4 times 4 times 34, 81. So plus or minus square root of 81 divided by 8. So we have 25 plus or minus square root of 81, which is 9, divided by 8. And so we have a plus and then a minus. So a plus, so that gives us 34 over 8 divided by 2, top and bottom, 17 over 4. And now subtract. We have 16 over 8, which is 2. Now we're going to check to see which one is correct. Right? So I have 17 over 4 x equals 17 over 4. So I have square root of 17 over 4 plus 2 equal plus, just substitute everything, 17 plus 4, 17 over 4 into x. So we just pretty much say 17 over 4, 17 over 4 plus 2, and then plus 2 times 17 over 4. So we do on the right hand side, give us 11. That doesn't work. Next, we test for x equal to 2. So this one is not good. We have 2 plus 2. Put 2 in for x, and here we have square root of 4 plus 4 equal to 6. Square root of 4 is 2. So that check. So x equal to 2 is the solution. Right. The reason we have to check make sure it works, because if we have something -3 equal to 3, it's not correct. However, when we square both sides, they are equal. So having this equal doesn't guarantee that without the square it will be equal. So when we square both sides, whether it is like this, which is good, or 3 equal to -3, which is not good, we have when we square both sides, both of them give us 9 equal to 9, but this one is not correct. So once again, isolate the square root, square both sides, and solve the equation. Make sure at the end we check the solution because we did square both sides. Right. Now, what happens when we have 2 square roots? Well, we can only keep one at a time. So I'm going to add the x plus 4 on both sides. Square of x plus 4. So isolate square root. So if we have more than one square root, we square one at a time. So 2x plus 1 equal to square root of x plus 4 plus 1. Now, square both sides. And remember, every time we do that, have to check the answer. Right. Isolate the square root. One square root at a time, because when we square, cancel the square root. Right. The right hand side may be a little bit complicated, but at least the left side is just 3x plus 1. Now, the right hand side we just have square of x plus 4 then plus 1 square. That means square root of x plus 4 times plus 1 times itself. Square of x plus 4 times square root of x plus 4, square root times the square root, that would be square of x plus 4 square. Square of x plus 4 times 1, and square root of x plus 4 times 1. 1 plus 1 times 1 is 1, right? Square cancel square root of x plus 4. Combine like terms. right? Now combine like terms again. Here's a 4 and 1. So we have 3x plus 1 equal to x plus 5 is 2, or square root of x plus 4. Right, once again we have a square root still, so isolate that square root and square both sides to get rid of that square root. So let's keep x square of x plus 4 on this side, move everything here. So minus x minus 5 . So here we have 2x minus 4 equal to 2x square root of x plus 4. Right. Not only that, here we can divide by 2 on both sides, so that we just have, remember, don't cancel the 2 like this, have to factor it first. We can cancel the 2 because that multiply together. Cancel the 2. So we have x minus 2 equal to square root of x plus 4. Right, now once again, if we want to get rid of square root, square both sides. And we have x minus 2 and x minus 2 square. We have just x plus 4. Right, x minus 2 square, x minus 2 times x minus 2. Multiply it out, x square minus 2x plus 4 equal to x plus 4. Right, subtract an x on both sides, subtract a 4 on both sides, so that we have a quadratic equation. We have x squared minus 2x minus 2x minus 4x minus 5x. 4 minus 4 is 0. So that's all we have. This is easy enough. Just factor out 1x and 0 product principle. Either we have x equal to 0 or x minus 5 equal to 0. So x equal to 0, that's what we have. X minus 5 equal to 0, just plus 5 on both sides, x equal to 5. Sorry, we shouldn't write like that because we do need to check the solution. Right, now let's put 0 in for x and 5 in for x and see what do we get. Right, first I put in 0. Right. So we have square root of 1 minus square root of 4, which is square root of 4 equal to 1. So 1 minus 2 equal to 1, and that doesn't work. So x equal to 0 is not a solution. Now we're going to test at x equal to 5. Put 5 in for x. That's square root of 16 minus square root of 9 equal to 1. Square of 16 is 4, square of 9 is 3. Yeah, that works. So x equal to 5 is the solution. Right, so when we have two square root, I'll just keep one on one side and square it. one square root at a time. Square cancel square root. Every time we square both sides, check the answer. And then just simplify the polynomial. We might still have square root. So isolate that, and then square both sides again. Of course, we will check the answer regardless, because we already checked the answer when we square the first time. So square again. That means we certainly will check the answer. And then just solve for it. Then check the answer. We have the solution. Right. Next. Equation in rational exponent. Equation with rational exponents. So here's some properties. B raised to 0 power is 1. So first, let B positive. And of course also not equal to 1, because 1 raised to any power is 1, so that's not really interesting. And we have these properties. Anything raised to 0 power is 1. Of course B is going to be positive here. Everything raised to the first power is itself. And the negative exponent, when there's a negative, we move the B to the move that to the bottom and change to the exponent to negative. Negative to positive. So here just say cross the line, change the sign, or change the sign, cross the line. So crossing the line, move B to the M from the bottom to the top, change the sign to negative. Right, that's what we have. Or change the sign so that we will cross the division line. Right, next B to the M over N. What's that equal to? Actually, so this will be equal to, the M is on the top, will be the power. The N at the bottom, that will be the root. Of course, you can also write that, and then all of to the M power. So bottom line is M is going to be the top is the power, and N at the bottom is the root. So power on top, root at the bottom. And then next, when we multiply two terms with the same two exponent, two power with the same basis, we just simply add the exponents. If we divide, we subtract, and power to another power, just multiply them. Right, now let's look at the first equation here. So we have 3 and 2. 3 on the top, by the way, rational exponent, so that will be the square root. Right, so I have x plus 1. 3 on the top, and 2 at the bottom. Power on top, root at the bottom. Right. Now, before we continue, just there's a step here. There's a note here. It says when taking an even root, including square root, fourth root, we need plus or minus on one side. So there are two rules in this section. Square both sides check the answer, or even root on both sides, check the answer. Take an even root on both sides, put plus and minus. So there's a two rule, and note that it only applies for even power or even root. Right here, we're gonna square both sides here, because that will get rid of the square root. So x plus 1 square right, I'm sorry, square root. There's a cube. Yeah. So square can do square root. We have just x plus 1 cube. And just as before, every time we square both sides, make sure we check the answer. Right. So 64 square 4096. And now the cube. And just like what we have before, the power cancel the root. At the same time, the root will cancel the power. But note that if it is an even root, there will be plus or minus. This will have a cube, so we're going to need the cube root, and cube root is not an even root, so there's no plus or minus here. If it is an even root, there will be a plus or minus. So we do need to check the answer because of raise both sides to even power. Right, so cube root cancel the cube. Right, cube root. If you're using this calculator, the cube root is under math. So hit math and option I think 4. So 16. And the cube root cancel the cube. So we have x plus 1 equal to 16. Minus 1 on both sides. X equal to 15. I forgot. Check the answer actually. Because we do square both sides, right? So I'm going to put 15 in for x. Raised to the 3/2 power. So that's 16. So I just say 16 to the 3/2. Yeah, so that check. Yes, so indeed x equal to 15 is the solution. Right. I say if you don't want to do this using the calculator, we can write 16 to the 3/2. 16, we can say 16 is 2 times 8, 8 2 times 4, 2 times 2. So 16 is 2 to the 4th power, because 1, 2, 3, 4. Now we use this rule, and we just say power to another power, we multiply them. And then 4 times 3/2, 4 times 3 is 12, divided by 2 is 6. And then 2 to the 6th power, 64. Yeah, so that's certainly we can do that without a calculator. Right, so two rules. Even root on both sides, put plus or minus. Even power on both sides, check the answer. Right, so here's another one. Plus 4 on both sides. So we have x minus 2 to the 2/3 equal to 4. Now, we write this radical. Right, now, power on the top, root at the bottom. Now, to get rid of the cube root, I'll cube both sides. Oh, this is x minus 2 square, right? Right. Once again, power on top, root at the bottom. Cube cancel the cube root. We have x minus 2 square equal to 4 cube. Should be 64. Now, square. So we will take the square root on both sides to cancel the square. Remember, every time we do that, there's a plus or minus. So once again, an even root on both sides, plus or minus. An even power on both sides, check the answer. So here, the cube root, that's not an even, the power of 3 on both sides, that's not an even power, so there's no need to check the answer here. So square cancel square root, we have x minus 2 plus or minus square root of 64, which is 8. So we have x minus 2 equal to plus or minus 8, plus 2 on both sides. The plus 2, the plus give us 10, and the minus 8 give us minus 6. Right? So we have x equal to 10 or x equal to negative 6. Notice that this time we cube both sides, so there is no need to check the answer. Or if we want to write as a solution set, can just say 10 and negative 6. Either way, that's what we have. But of course, if we want to check, just put 10 in here. 10 minus 2 is 8. 8 to the 2/3 is 4. 4 minus 4 is 0. Now if we put negative 6 in here for x, we have negative 8. And once again to the power 2/3. It's also 4. 4 minus 4 is 0. But once again, cube root on both sides, it's not an even root, so no need to check the answer. I'm sorry, it's not an even power. Cube on both sides, no need to check the answer because that's not an even power. Square root on both sides, that is an even root. So we put plus or minus on one side. So on that, I'll need to make sure there's a two rule. Even root, put plus or minus. Even power on both sides, check the answers. So those are two rules, very important rules in this section.